Hi guys, in this problem we'll be solving Leetcode 213 House Robber, House Robber 2 in fact. So if you have not seen House Robber 1, I would suggest you guys to go back to my channel, see that video. I would also link that video down in the description. Uh, what is House Robber, right? So we are given an array just like House Robber 1, 1, 2, 3, 1, right? In House Robber 1, uh, the robber had to decide which houses he wants to rob so that he won't get caught. How would he get caught? So if he robs the house 1, right, and he goes to rob the house 2, what is 1? 1 is the house, first house with value 1. I mean, suppose it's 1 lakh or 1 crore or maybe $1 million or something. So that house has $1 million in it. The second house has $2 million. The third house has 3 million. The fourth house has 1 million in it, right? So if he robs the first house, he cannot rob the second house because here the burglar alarm has gone off, and the neighbor, the immediate neighbor, is now aware that okay, there is a robbing in my neighborhood, in just my immediate neighbor, right? So if he robs 1, he cannot rob 2, but then immediately until 3, the third house is being notified that there has been a robbery, he can go back and rob 3, right? So if he robs consecutive houses, right, immediate neighbors, then he will get caught, right? In that house robber 1, right, he was choosing 1 and 3 to get 4. Our problem was to maximize his earnings, right, to get as much money as possible in his bank account. So 1 comma 3 he gets 4, or he can not choose 1 and he chooses 2, and with 3 he can just because he's chosen 2 he cannot choose 3, he can choose 1 now, right? So 2 comma 1 he gets 3. That was his maximum possible earnings, 3 and 4. We used to take a max of it and then give out the value 4, right? In this situation, in house number 2, in Leetcode 213, we have given a problem where there are circular houses now, right? Circular houses. So 1, 2, 3, 1. So it's in this way. So now if he robs 1, he cannot rob the house just before and just ahead of it. Earlier it was 1, 2, 3, 1. So there was no before, so he doesn't have to worry about that. He just has to worry about the next upcoming houses, right? Um, in this case, he also has to worry about the before, right? So if he chooses to rob 1 and chooses to rob 3, right, that is still fine. But if he chooses to rob 1, not choose rob 2, not choose rob 3, that is still fine, it still meets the conditions, right? But if he chooses to rob 1, he might get caught, right? Because he has already robbed this house and there is police here, so he can get caught this way. That this one is his immediate neighbor for this one, right? So this is like a circular fashion. So how would we solve this problem? Just take a smarter approach. So he has decision making just at 2 places, right? So earlier we had 1, 2, 3, 1. The middle houses, those are not affected. Those are still the same as we were doing in house over 1, right? But just the houses at the ends, these are connected again, right? These are connected like this. So we just have to choose, we just have to decide which house should I rob, right? There can be, again, whenever we think about DP, this is the problem of DP of course, right? So whenever we think about DP, we should be thinking about brute force approach and then to memorize it, right? So what would be the brute force approach in this case? We have to go all out. We have to think about all the possible earnings he can earn and get the maximum of it. What can be the max, all the possible earnings? Suppose if he chooses this house, obviously he cannot choose this house, right? So he is left with the rest of the array, right? So 1, 2, 3, just because he's choosing this house, right? He's choosing this house. If he not chooses this house, he has not chosen. With choose, it's this one. With not choose, you guys can see here. With not choose, he is not choosing this house. So 2, 3, In circular array fashion, he has not chosen this, so he can drop the last house as well, right? So 2 3 1. So this is one possible combination. He can do house robber in, house robber 1 in, and then this is one particular combination. He can do house robber 1 in, right? What we gotta do, suppose he gets, what is the maximum earning he gets here? It's 3. What is the maximum earning he gets here? It's 4. It's the same we were doing in the earlier array approach, right? 3 comma 4 and get mat.max between them, right? Mat.max gives 4. This is the answer for this. Let's go ahead and try to code it out. Firstly, before that, what would be the time complexity? You would need a different array to store the remaining items, right? So 1 2 3 and 2 3 1. So that is O of n there for storage. And house robber problem, if you see, we were doing it in O of n time and O of 1 space, right? We are using last and second last there, so O of 1 space. But here we are using extra array, so O of n space and O of n time, right? So that would be the best possible approach for this problem. Let's try to code it out. Okay, let's try to code out our house robber 2 2 1 3. Let's try to code the house robber 1 function here first. Public int, it will return us int rob house, right? Int head arr if bracket arr dot length equal 1, return arr of 0, right? That's just one house, so return that robbing. And let's take now int second last. Let's do sl second last is equal to arr of 0, int last is equal to mat.max of arr of 0 comma arr of 1, right? We were doing a for loop, int I is equal to 2, I is less than arr dot length I plus plus. We are going until the end, right? We were storing our last in a temp, int temp, just because we'll be iterating the last and we'll be changing the last, right? So we have L here, then L is being changed. What is L? L is mat.max of the earlier element, that is L, and second last plus arr of I, the current value, right? If you guys want to know more about this function, you guys should watch the house robber 1. That will give you a detailed solving of house robber 1 with brute force and optimized approach as well. And our second last becomes last, right? What we will be returning, return last, we are returning L, right? This is our rob house function. Again, if you see the earlier explanation, we were dividing our array into two parts, skipping the first one and skipping the last one, right? And then we were giving it out to the rob house function and getting the max of it. We'll do this exactly the same here. If we'll try to do nums dot length is equal to 1, then return arr of 0, and int arr is equal to new int. Just because we're skipping one element, we'll do nums dot length minus 1. Maybe this makes sense, right? We'll do first, skip first. This is basically an int array. Last is equal to new int nums dot length minus 1, right? We have to store these elements because just initializing them, it's 0. Int I is equal to 0, I less than nums dot length minus 1. I'll tell you why we are not going to the last element. You would understand that better here, right? For first of I, yep, so we are skipping the first element, right? So and this is going until the last second last element, nums dot length minus 1, and I is less than. So we'll do nums of I plus 1. What this will do is it will skip the first element. I mean, of course, first of 0 is nums of 1, right? Skip the first element, and when it's nums of n minus 1, that is the second last element, our first will be storing the nums of last element. Did you get it? then last of I, just because we are skipping the last element and our for loop is by naturally skipping the last element, so nums of I, this will take care of it. Now return mat dot max. We were doing rob house of first comma rob house of last, right? Let's try to run this. Okay, it says error 0 line 4. Okay, it's nums. Okay, it says accept. Okay, it says wrong answer, so it go back. See, yep. So this is the problem. So when you go here, it should be temp, right? We are changing the last and we are storing the new last in the second last. So let's run it again. Let's try to load it. Okay, so this is of n here and of n here, of n here, so total of 3n auxiliary still of n and space of n minus 1, but still n.